Um, so I guess welcome to the November Building Operators Association webinar. It's a nice snowy day here in Calgary, so hopefully everybody is hunkered down. And anyway, a couple things. As you know, we've been following we've been trying to do the topics following kind of the COVID-19 challenges in the HVAC industry, and so previously we've had a webinar from Honeywell on generic on systems, how they're affected by COVID. And then another one on filtration by BGE, which is an excellent one. And now today's seminar or webinar kind of fits in nicely as well, because it along the themes of what are some of the things that you can do in your building to try to improve the indoor air quality. And as we all have been kind of following in the news, the virus is airborne. So you know, what exactly can we do from an HVAC point of view? And so with that theme, I think Joanne Ogilvie with Sanuvox, and I'm sorry I'd forgotten your name again.
Reagan.
No
Reagan.
problem.
Yeah, we'll be doing the presentation,
right.
And then if I can ask that participants just type in your questions as we go along, and then towards the end of the seminar, then we can see if there's any questions that anybody. Like, what I'll do is just go over them verbally, and then we can answer any questions you might have. So this is an interesting topic. And so we have, you know, lots of time to go through, so there's no panic on time. Just have to keep it somewhat reasonable and to the point, and to H, and possibly get into some, I don't know, room disinfection or something like that if we have time. So further ado, I guess I'll mention one other thing to our membership. Don't forget to go on to our website, boacalgary.com, and sign in and pay your annual dues, because it helps us out with our cause. And also you have access to the magazine, which you can download, and check out our interesting articles. So anyway, Joanne, I understand that you've got 20 some years in the HVAC industry as or 20 plus
20, yes,
as a mechanical engineer or
technologist, mechanical
technologist. Okay.
Technologist, yes, and I've
so you have been doing the indoor air quality kind of theme for at least three or 4 years.
I've been, well, indoor air quality has always been associated with HVAC and refrigeration units. So I've been exposed to this for many, many years. Yes.
Yeah, as we all have. Yeah. So so anyway, I guess we might as well just let you take it away there and go through your presentation, and I'm sure we'll get things rolling as things progress.
Excellent. And if there's any questions, or if you want to interrupt me, just go right ahead, pretty cash. Okay, so I'm just going to explain UV. People are not fully aware of exactly what kind of spectrums we utilize for doing air disinfection and surface sterilization, as in coil cleaning. So with UV, there are 4 UV spectrums. UVA and B are naturally here on the Earth's surface. They are not as strong or intense as the UVC and V spectrum. But as we see here, UVA, this is when you get a little bit of a suntan. UVB is when you get a sunburn. It's much more stronger. Now, these two, UVC and V, are up in the atmosphere naturally. And they are so strong that if they were here on Earth's surface, we'd look like the moon. Everything would be completely destroyed. Now, we utilize UVC at 254 nanometers, and that is a perfect nanometer range to do a germicidal treatment. The other spectrum that we work with and that's available is UV. Now that's a vacuum UV spectrum. That is a molecule change. And what happens there is the molecules, hydrogen and oxygen molecules separate, they become hydroxyl radicals, and that's where we would acquire the odor removal function. So anything to do with killing germs and removing odors. The company I work for are one of the only companies that have, first of all, commercially sized equipment to work with commercial systems. The other thing is we're one of the only ones that actually use both of these spectrums. There's some other technologies that I'll speak of in a minute that try to acquire the odor removal a different way. Now, basically indoor air quality, we're always concerned with bacteria, contaminants like smog, wildfire smoke, particles and stuff, pollen, etc. A lot of people that have allergies are greatly affected by the air quality, and not just allergies, but asthma and stuff. Anybody with respiratory system issues and stuff, the indoor air quality is very important to them. Of course, big topic right now, viruses, COVID-19. Influenza A, which H1N1 is a subtype of, is also a highly infectious airborne disease, along with TB, along with measles. So our systems, UV, will destroy these pathogens. It will not stop the contact. If you touch somebody that has the virus, it won't stop that. But we can absolutely destroy the pathogen that's in the air. We also deal with, as mentioned, with odor removal. So we're talking food odors, garbage rooms, etc. And then, of course, there's also facilities that either pet shelters or SPCAs, etc., where we have animals that are also viruses playing a role there. We've got the parvovirus virus for dogs, cats have viruses, etc. But also there's the odors generated from the animals themselves. So there's a wide range that we can use UV to treat. Now I'm just going to talk about surface sterilization for a minute. Actually, no, I'm going to go back. Let me just go back to this screen. So how do we deal with indoor air quality? There's filtration and there's also UV. Now with filtration, I just want to explain, it captures, it does not destroy anything. And so if we're talking about the COVID-19 virus, the COVID-19 virus is 0.1 micron size. A HEPA filter will capture 0.3 micron size. And so essentially when you think about this, can a HEPA filter, which is the best filter you can get, can it actually capture the virus? Well, it can, but by accident. There is no way they'd be able to give you a percentage because it'll capture 0.3 of microns at 99.99%. But these viruses are 0.1 and smaller, 0.098. They can physically get through a HEPA filter. Now, what happens though is when these pathogens are flowing through a filter, they are so tiny that they end up, their directional flow becomes chaotic because they start bumping into gas molecules, and they'll get slammed against the media of the filter. And so really a HEPA filter, or even a MERV 15, high MERV ratings and stuff, what they'll do is they'll capture it, but it's just by accident, as in it'll get slammed against the media. So it's either through diffusion, interception, or impaction. Can they give you a specific percent of catching it? No. But the other thing that you need to be aware of is, are you going to start sending out your maintenance people to site to filters in hazmat suits? Because it's very likely if you have the COVID-19 virus in the building, that virus, for whatever reason, and we don't know a whole lot about the virus, but it stays viable for many hours. And so this person that needs to go change a filter can be exposed to COVID-19. So what I like to say is that we encourage both treatment, UV to destroy it, and filters to capture the destruction of the pathogen, not capturing live virus. And I just wanted to just talk about that for just a moment. Now, the other filter out there that affects different odors, like in animal odors or food odors and such, lingering odors, is carbon filters. Carbon filters saturate very quickly, and they are very expensive to replace, and you can't wash them out and reuse them or anything. So what we can accomplish with odor removal is a lot less expensive than doing it with carbon filters. And we've learned that actually through the indoor grow facilities of the cannabis, where they have issues with odors of their building. So the very first thing I would like to speak of, we have two different types of disinfections. We either do surface disinfection or we do air disinfection. So with surface sterilization, we have a few different choices, and one is that we can, in the middle, we can surface sterilize products that run through a conveyor belt. So we completely destroy any contaminants that are on, and this happens to be apples that are running through this conveyor system. Now, the other thing that we can do is we can do a surface sterilization in a combination of UVV. And so this is in a walk-in cooler. If you have any walk-in coolers, cafeterias, etc., that you look after, the shelf life of the produce will increase immensely. This keeps the ethylene levels down. And so if you're looking after any of the cafeterias and stuff, this would, restaurants, whatever, this would be very beneficial. Even flower shops, it's the ethylene levels that degrade the flowers, of cut flowers and such. So we can do a combination of UVC and UVV to give us that control over the ethylene levels. One thing I want to talk to you about that's most important is the coils, the evaporator coils. Now, with the AC coils, what happens is bacteria collects on the fins, and that bacteria actually forms a bacteria biofilm that compromises your heat transfer. And so your equipment's working harder to meet the set point, much harder. And also, that bacteria biofilm is sticky like glue. And so usually you'd have to get a refrigeration technician in to clean these coils with a chemical coil cleaner. And that procedure, you'll never get the coils clean in between the fins. Bacteria biofilm returns very quickly. So if you put UV on the coils, there's the first main advantage is the cost of running the AC, it drops dramatically. You don't have that compromising of the heat transfer. So your equipment's running more efficiently and less cost to the building. Now, the other thing is that you drastically reduce the necessity to hire a refrigeration technician to come in and manually clean these coils and wash them out and use chemicals, because that UV will keep them clean. And the last big bonus is it is a huge preventative of formicary corrosion from ever developing. And so what happens is when you get that bacterial biofilm on your coils, the water starts pooling and it turns acidic and starts pitting your copper tubes. And that becomes a equipment failure and is called formicary corrosion. So if you have clean fins, you don't have that situation from ever developing. So these are quite important things that would be a benefit. Now, whenever we size out a coil clean, I basically need the size of the coil, and it doesn't matter if it's like 120 inches long or you know, it's 6 feet high, whatever. And this is kind of an example of what you would get as a result of calculation. And so what we have here is the coil size and the type, and then you have a visual of your treatment. We always want to get all 4 corners of the coil. And then also minimum dosage engineering firms will, they say 232 microwatts per centimeter squared is the minimum. And then with this calculation, I have here the black mold, Aspergillus nigrospores and stuff. We would calculate it out to, I have a couple things in there actually. We also give placement of on that coil. Sometimes you might have to have two rows, you might have to 3 columns. It's all very dependent on the site. And then of course we would also provide whether it's upstream or downstream location. So air moving through the coil at the lamp would be considered a downstream, whereas if the air is coming this way, the lamp's located here at the coil, that would be upstream. When you have a downstream application, you have the air going against the lamp. This will promote fouling. So we do have in our calculation to accommodate for that. Fouling is collection of dust. Anybody that wears glasses, we walk very slow, our glasses get dusty. So we've got a lot of air coming through, and if you have the lamp on the downstream side, that air will go against that lamp, and fouling will happen. The preferred location obviously is the upstream, where the air is coming in from behind the lamp going through the coil. And then this one just sizes out exactly what position mathematically, measurement wise. And so that's just an example of the coil cleaning and such. Any questions on this at all?
Not so far, no. I think,
Okay, so now let's
as
talk.
we keep going, there'll be questions later.
Sure. Let's talk about air disinfection. Air disinfection is different than coil cleaning. It's all about time and intensity. So with coil cleaning, the coil moving. We have all the time in the world. You just have your UV right there at the coil, nothing's moving, and it's doing its job. With air disinfection, we have pathogens and stuff moving through the air very quickly. And so a very low CFM, like 700 CFM, a pathogen or a spore will move over 5.5 feet in 1 second. And so we calculate out things that are important. We need to know the CFM, we need to know the duct dimensions, we figure out the velocity. We need to know the material of the ductwork. And these are all things that affect how we size out the equipment. All commercial jobs are sized out independently. There's no commercial job that's identical. So we have 2 different solutions for air disinfection. We can do a standalone unit that will do a room, or we can do an duct system. And we have I just put some pictures on here. We have a new unit of an S100 100 CFM that'll do a small room, about 500 square feet. These have been excellent for in schools, basing on ASHRAE's recommendation of 10 CFM per person would basically kind of tell you how many of these units you would need. And this guy is really quiet, S100, that's great for small offices and things like that. It's at 40 dBA at 100 CFM. There's 3 different speed choices, but 100 is the maximum CFM. We also have standalone units, and this is all based on cubic feet of the space. And so again, sizing is involved as to which unit would be appropriate, and not just the cubic feet, but we need to know what we're sizing it for. Are we trying to kill COVID-19, or are we trying to kill in an application where there's spores and stuff, a lab, etc. Now with the S300, it's basically 300 CFM, and these units come complete with the UV treatment, and then we also have a MERV 8 pre-filter along with a HEPA filter, so you get great filtration along with that UV treatment. And so with this, we're looking at probably on a commercial application, anywhere from like 2,400 to probably about 4,000 square feet. Again, dependent on the contaminant, what we're trying to kill, and what the application is. The S1000 is a 1,000 CFM unit, so a much larger volume of air movement. We can put up to 4 lamps in here, so again, very dependent on the application. And also is, it can have a MERV 15 filter, it can have a HEPA filter. We can also put in carbon filters if that's required. There's all kinds of different options there. My last standalone unit here, the S600, this is a garbage room unit that is compatible with many sized garbage rooms. It comes complete with 3 lamps, 100% UVV, and the installer would determine how many lamps to activate depending on the cubic feet of the room. We've done a lot of garbage room with all 3 of these. We equip this with an ozone monitor for garbage rooms. Do garbage rooms very well. And there's a condo actually just on Princeton on downtown Calgary. It's I don't know, I think about 22 stories, and they had an issue with the garbage room smell going up the elevator shaft along with the chutes on every floor. And so they had a real situation there, and the tenants were not happy with the situation, and they put in that garbage room sized out to an S300, and it was very immediate. And the condo board manager, the property management group, and the owner of the building, they were taking people for tours of the garbage room in their parkade because they were so proud of it, because you could stand in there for a long time and it didn't smell at all, and such. We do smoking rooms. There's a lot of schools and such that are introducing smudging rooms, which essentially their Indigenous students are smoking pipes and creating little fires and things like that. And they don't want the building to smell of such. There's all kinds of different types of odor removal. Sometimes you have some specialty restaurants with ethnic food that have odors that bother neighboring tenants and things like that. So we can deal with all kinds of stuff like that. The induct system, this is our light commercial unit, the Quattro units, torpedo of 4 lamps that are 18-inch in length. This is good for a small, maybe a 5-ton and less. And again, it would be sized for the contaminant. So if we're doing with COVID-19, I would size it for that. It's very dependent on the site conditions. The BioWall is a torpedo of 5 lamps, and that comes in many different lengths. Now, one unique difference between the product line, the Sanuvox product line, and others out there in the market is that we have T6 lamps. The lamps are made of quartz, which emits the two different spectrums. They're higher intensity, and the lamp life is longer because of that. These ones are determined the size. They come in length from 18-inch, 24, 30, 40, 50, and 60-inch, so all the way up to 5 feet. And depending on your duct dimension, if you have a duct that's about 60 inches wide, 5 feet wide, we would probably have to have 2 windows in there, because we want to make sure that we get all 4 corners of that ductwork with treatment. But again, it's something that I would size out for you. The lamp length in all the commercial products are 2 years. They magically just stop igniting. They will continue to ignite. But what's going on here? So anyhow, on the BioWall, we have a 15-year warranty on the ballast box and control. We also have this one here is a 3-year warranty on the ballast box and such. And then these guys here are a 2-year warranty on the lamp and 3-year warranty on the motors and things like that. Actually, the motors are 1-year warranty. That's for pretty much anything. So I just want to talk about dwell time and how we destroy COVID-19. So with the Sanuvox products, we position all of our torpedoes in the ductwork parallel with airflow. And this is really important because we get a longer time period of exposure to this UV. Now, most other UV products out there on the market, they put in the units perpendicular with airflow. So really all they're getting for treatment is that diameter of that lamp. And so with our systems, with the Sanuvox systems, the lamp is positioned parallel. You get a nice long treatment. So we take a look at the comparison. Bacteria is very easy to destroy, and pretty much all of them they'll do bacteria, but they will miss most of the viruses and the spores because they simply don't have the length of time of exposure to them. Whereas with our units, we have this is part of our calculation and with the length of time of exposure to ensure that we have a kill rate of that particular contaminant. Now I'm just going to speak about a couple of different indoor air quality things out there, technologies. So you may have heard of PCO technology, photocatalytic oxidation. And what that is they'll have a UVC lamp, and they'll introduce as a catalyst titanium dioxide. And what that does is create a chemical reaction that creates hydroxyls and separates the hydrogen oxygen molecules. They become radicals. The problem with PCO technology is the titanium dioxide reacting with UV has a byproduct, and that's formaldehyde. So all of the PCO technology equipment that has titanium dioxide as a catalyst are all creating aldehydes, formaldehyde being one of them. And with the use of having UVC and UVV, there are no VOCs created at all. And it's kind of funny to read about some of the PCO technology stuff because their big thing is that they destroy VOCs, but what they don't say is they're creating a VOC. They're creating the aldehydes. The other technology that's out there is ionization. And what ionization is they electrically charge the ions. And the idea is that these ions will swell and clump together, and then you catch it in the filter. Now, when that electrical charge depletes, what happens? Well, it just goes back to its normal state and then off through the HVAC system. It does not break the DNA of spores and bacteria or the RNA of of viruses. It doesn't do that. All it does is make them swell, clump, catch. So I just wanted to bring you up to speed on those things. You can look into this in more detail with the ASHRAE handbooks. You'll find one chapter on PCO technology. You'll find nothing on ionization. It's not a proven technology that works and safe, but you will find 2 full chapters of UV in ASHRAE. UV has been used at 254 nanometers for over 100 years in water treatment for bacteria and things like that in water. And we are basically doing the same thing here, but with air. Now, in ASHRAE, in their chapter, they also have a chart of reflective qualities of different materials. So when we take a look at the duct work, this is really important. This really is a huge contribution to the sizing. If you have galvanized steel as ducting, it's only 25% reflective. And we do have a reflection coefficient that we input in our calculations when we're doing it. But if you upgrade the ductwork to aluminum, aluminum is highly reflective. And so all of our extrusions and this deflector on this unit shining on this coil, this is made out of aluminum. It's 85% reflective, and it enhances that germicidal treatment of breaking the RNA of the COVID-19. If you have an acoustically lined ducting, it's 0%. And there's no reflection there whatsoever. And so that will affect the size of the treatment that needs to be had to do the job that you want it to. Now, the stainless steel and chrome, even though they reflect visible light, they are very absorbent of UV, and they do not reflect UV hardly at all. So stainless steel and chrome are not great. The best thing you can do is aluminum. Let's go to the next one. These are just some examples of some of the units that are installed. So we have the S100 can be ceiling mounted into the T-bar drop ceilings. We put this guy like 6.8 100 CFM. We have an induct system for a light commercial application. This has been quite popular in dentist offices and smaller offices and things like that. We have a garbage room. This is a 1000 unit. Coil cleaning, of course. We can put these right inside the air handler, right at the coils. We can also do the bio walls inside of an air handler if there's enough room. Again, we position this parallel with airflow, so it has to be parallel with that air. But typically the choice is either return air, or it can be in a supply air as well. And then this one is just surface sterilization of product going through. But walk-in coolers, it would be just the ILs right at the refrigeration unit. Now, just briefly about Sanuvox. We've been around for over 5 years. Dr. Braze, he's our founding owner, and he has his doctorate of nuclear engineering. This is all of his calculations and his work. And he heads up our engineering group, and he's always on work. So I just want to briefly talk about something that happened in March. His daughter is a medical doctor, and he designed a system to sterilize the protective masks that the medical industry use, and he was just right on it right when that happened. So that's a little bit about that. I invite you to go to our website, sanuvox.com. You'll find a blog, under news, you'll find a blog section that has scientific papers. You'll find case studies, you'll find white papers, all kinds of stuff. There is one other thing I just want to show you, because I know that you guys are all interested, is now I can maybe zoom in on here. This is the kill rate of the contaminant. How much of a dosage does it take to destroy? And so we have the exact dosage of what it takes to destroy the COVID-19. We have the, we had to send data to a specialty lab in France several months ago and stuff. So I'm just gonna zoom in here so that we can have a look. Oops, I need 2 fingers to do that. So if we have a look at this, influenza A is actually a little bit harder to destroy than the coronavirus. Let me move this chart down here so you can see. So the COVID-19 is up here. And so we have all these kind of, I'm certain that you've probably dealt with some of your buildings with listeria, et cetera, but we can choose any contaminant to do a sizing to. So with COVID-19, it's actually fairly easy to destroy. We would not want to recirculate it, so we want to destroy it on the first pass of the lamps. Now, something that's a little bit harder to destroy is H1N1, and so we look at that, and it's a little bit harder. But we can do measles virus, the avian flu virus. We've got one here for the doggies, the parvovirus, but we also have many other things. We go into even spores and stuff. So we have Aspergillus niger, et cetera. There's the database is enormous, Norwalk virus, et cetera. And so this chart just kind of gives you a snapshot of this. So when we do sizing for a commercial building, we're providing you with real information, and that's important to know. So that, I think I did 20 minutes. Oh my goodness. So that's my little slideshow presentation.
Well, thank you, Joanne. Yeah. There is a one question that is up there from actually from the Canfill rep, but I'll ask maybe a couple questions before we get into that, and it'll sort of lead up to it. So for the 2 things I'd like to ask is you mentioned the dwell time is key.
Yes.
So that the lamps have an opportunity to kill the virus. Now, I guess that would be for both the coil and the induct applications.
With the coils, I typically size it to be 12 inches away from the coil itself. These are factors in our sizing software that we input. I mean, I can go as close as 8 or 6 inches, but then you shorten your beam. And so when we have a large, big wall of coils, that would, we would 12 inches, we can go 14 inches, but 12 inches is kind of the normal. The distance from the lamp it's important. Now the fins are typically aluminum. And so, as I mentioned, aluminum is highly reflective. And so as long as those coils are not deeper than 12-inch thick, about a 12-inch distance from those coils to the fins, it's fine. So
then it's a question of just working around the filters or reconfiguring or whatever.
Yeah, so if you have the air, if you have the air coming through, and you have the lamp shining on the coils, the air is going through the coils, and then you have your filter after, that's a perfect scenario.
Yeah, but usually we try to filter before the coil, right? So,
right. Yeah. So I've been in many air handlers and stuff, and you get a lot of bag filters and stuff like that. So that becomes a downstream application, which is no big deal. I would just size it to downstream application. And so we have air coming through those bag filters and the lamp position shining on the coils, and now and sorry, that would be an upstream, but you just don't have the filters after, so it doesn't really matter. The pathogens and the contaminants, when you break the DNA or the RNA, they are unable to reproduce at all and die very shortly thereafter. So if you have very dirty coils, when you first put the UV on there, you may get a lot of stuff that comes in the drain pan, and that's killing all that microbial growth and stuff. And then soon after, a few weeks later, it's going to be a lot more pleasant to be in there. But it will start working right away. There was a contractor that kind of tested, how long does it take to clean a coil that's plugged solid. And so he put on the Sanuvox UV on a plugged coil, and it's 22 days and it was clean as a whistle.
Well, that's interesting. So I guess from an airflow point of view, or a CFM point of view, or I suppose with the coil application, is that also a factor?
No,
or
it's
is it just in ducts?
they're very small, like it's probably about 2 inches, so that you would have them positioned in rows or columns. So it'd be very little, not even a measurable pressure drop. The in-duct system, when it's parallel with airflow, again, not even a measurable pressure drop, because it's right with the air.
Yeah, I wasn't referring to pressure drop, but rather, is there a limitation to the amount of airflow in an air handler, as for, your sizing application, like duct versus small?
No.
There could be a large difference in velocity, right?
Yeah, no, I've sized things that were, I don't know, well, I did one the other day, it was like 63,000 CFM. It's all very dependent on the duct dimension, or if you're putting it inside an air handler. I have run across some of the, sometimes you don't have, I would need a minimum of 72 inches to accommodate 1 biowall 60. And so if the system is that large, and the duct work, if we can position a row of 3 or a row of 4 in that duct work, great. But if the duct work is smaller, and we have to have 2 biowall 60s one after another, then that means that we'll need at least 10, 15 feet. No, it'd be long, 12. Yeah, you'd need probably about 15 feet.
So then, yeah, you gotta, so you need a nice run,
yes,
of duct, and then as far as the putting the reflective material in there, the aluminum, then you can just add that in.
Yeah,
right?
it enhances it greatly, to the tune of you will need equipment 4 times smaller.
So the other thing that kind of relates to this from a safety point of view, UVC is, excuse me, exposure to it from guys working on it could be an issue.
Yeah,
So
I always supply kill switches for the access door. So as soon as that door opens, the lamps go out.
Yeah, and there is kind of a placard that goes on. Is there? No. Placard on the duct so that somebody knows not to expose themselves.
Yeah, if you look at the bottom of this, right, they don't want to. So Joanne, just a note, you have 3 questions to answer at the bottom there.
Oh, okay. Yeah, sorry, I only do one thing at a time. I will look at those questions.
I'll do the questions for you.
You
Okay, deal. I didn't know if you saw them either.
So exposure, you would never ever want to ever look at the lamp directly. You will get welder splash immediately. That's why we always equip a kill switch for the access door. As soon as you open that door, the lamps go out. Now, regular maintenance, all that would be required is simply just to wipe the tube maybe once a month with a soft cotton cloth. That's it. Some places like to use rubbing alcohol and things like that. So very little maintenance. Now you will have to change the lamps because, as I said, they don't just magically just stop igniting. They will continue to ignite, will not be emitting the amount of dosage of the UVC treatment to do the job that you wanted it to do. So those are important things. Now, how do you dispose of the lamps? Well, the lamps are exactly like a fluorescent lamp. So you would dispose of them exactly the same as you would a fluorescent lamp. Exactly the same.
Okay, so the first question from Canfil is, we may have already answered this, but he's talking about, he says it certainly makes sense that UV at the coil is beneficial for the surface. However, airspeed in a commercial AHU is 9 kilometers an hour. I've never seen it
Well,
burned that way. But and
you
4
can,
times greater in ducts, is it possible to kill the viruses that are airborne in incredibly small contact time? And he says 500 feet per minute equals 100 inches per second.
yeah.
And
So
a 5 foot long lamp.
so most systems are the velocity is around 500 linear feet per minute. That's how you size out the ducting with the CFM, and so it's absolutely doable. That is an average typical velocity. Almost all of them are about 500.
Yeah.
Mm-hmm.
Okay, so and again, it's a question of just getting great dwell time and all that kind of mess. You have to size for
That's
every
right.
application.
So let me just share my screen again. I'm just going to show you a document I made up, and basically I have here. Let's go to here. So I just made up this. This is 2-pager. So basically, you know, what contaminants are we going after? You know, so I've got the COVID-19 on there, influenza A, measles, listeria, Legionella, all that stuff. And then, you know, are you wanting some odor removal or not? You know, is going to be garbage room, etc. So if it's a standalone unit that we're looking at, we need the room dimensions, but this is also important for me to figure out the number of air passes per hour in the induct system. So this is an important piece of information there. And so basically what facilities do is they basically just list out, you know, if you give me your tonnage or the CFM, and then basically supply, provide. Are you putting in a supply or the return air duct? We are concerned with air temperature. If you're bringing in outside air and it's minus 30 outside, the lamps will be affected for ignition. So if you have a duct heater or whatever, usually you have to make up air, and you have like an average of, I don't know what, 17 degrees Celsius or something, which is fine. But if you're bringing in cold, fresh air from outside, I would recommend putting the system downstream a bit, downline. And then if you're doing supply, are we doing the main supply, or are we doing supply runs? So there's that difference. So there's always that option. If you don't have enough room in that main supply, but you might have for the runs. And then the dimensions, of course. Then the duct material. So again, this is really important because I need to know if it's a galvanized, is it acoustic lined, or is it aluminum, because that will affect the sizing. And then the coil, the smaller systems may have an A or N coil, but you have your slab coils. And I just need to know the width, the height, and then if it's a walk-in cooler, I need to know if you need it Teflon coated or not, because if you it's what we call our food safe grade. So if somebody bumps that lamp or you know, they're changing it and it drops and it shatters, the Teflon will keep it together so we don't have a gazillion little shards of quartz everywhere. So there is a Teflon coated available. And then this is more for my own, but I need to know, are you putting it upstream, as in the air flowing past the lamp at the coil, or it where the air is coming through the coil at the UV? So there's, and that's pretty basic. This is really all the information I need to be able to size and run a calculation for you.
Okay. So the next question is up here again. is from Michael, and he's asking if a HEPA filter doesn't catch COVID, then how does the coil?
The coil, now, this is very important. Coil cleaning is not a air disinfection, and I would not recommend coil cleaning for COVID. Now, what happens with viruses and such is they get trapped into that bacteria biofilm. And if they dislodge and get an airstream, well, then they're off and away they go. With spores, like black molds or mildewy spores and stuff, if they get trapped in that bacteria biofilm, it's like an incubator. And so they go through this incubation, and then they're like primed to multiply because they just went through a very cool, damp period. And so coil cleaning is not air disinfection. You will not get great air treatment disinfection on your coils, just treating your coils alone. What you will do is you'll get more efficient operation on your coils, and your coils will be clean, and you'll have a lot less contaminants and dust particles and things like that collect on the coils and having plug coils.
Okay. So the other two questions are just another couple comments from John Holmes again, sort of further to his first question about contact time,
Right.
dwell time. So I don't know if you want to speak to that or not.
Okay. Do you want me
Can you
to
see the question?
pull up that shot again of dwell time?
Yeah, I don't know why he's getting hung up on that, and I guess he's commenting on if the light drops or the light would drop exponentially the further away from the lamp, but then that's where we're talking about the importance of the reflectivity of the ductwork.
Right. So back to the dwell time. When you have a fixture positioned parallel with airflow, we get a very long dwell time. Now, that length is determined by a calculation. We need to know what we're sizing for. What are we killing? And we size out the most appropriate length for the pathogen within the velocity given. So what this is indicating, bacteria are really quite easy to destroy, to break the DNA of. Spores are very difficult. So in comparison, black mold would take a dosage of about 330,000 microwatts by second per centimeter squared to break the DNA of Aspergillus niger. Whereas when we look into a bacteria like TB, it'll take about 10,000 microwatts by second per centimeter squared. So we can kill the TB off very, very quickly and such. So when we're talking about those viruses and stuff, the COVID-19 is sitting about, I believe it's around 50,000 microwatts by second per centimeter squared. The difference here is when you have a lamp positioned in the airstream, okay, so in the airstream, perpendicular with airflow, it's only getting the exposure lamp just on the diameter of the lamp. There's no long dosage time. And so that's what we mean by time intensity or dwell time. If we take a look at this particular sizing, we give the a kind of a picture, if you will, of the dosage in that ductwork. And so the intent is to not have any black at any of these corners, because this is treating the entire ducting along with the air coming through. We don't want to have just a little circle here and everything else black. This is why it's very important to give those duct dimensions so sure that we have treatment on all all sides of that ductwork.
So do you find that it's more effective to install the in branch ducts or in mains
Uh,
as
you know,
far as
very-
achieving
yeah.
the dwell time?
Yeah, it's all very dependent. If you don't have room in the main, then we can look at doing the separate branch runs. But I haven't run across that. Only one actually where we have to do a special calculation to angle them at a 45-degree angle because it was impossible to get to the ductwork, and they had to be inside the air handler, and there wasn't enough length, and so we did a 45-degree angle with an extra special calculation for that.
Oh, okay, all right.
The whole cosine sine.
Yeah, I can imagine. It
Figure out
gets a
the
little-
angle.
So again, John is going nuts here, but let's see if I can pick out one of his, always going on about HEPAs. I think he's overthinking this, but he's just sort of questioning your 0.1 micron your comment about the HEPA filters and not being able to stop COVID. They can stop it. It's just if you have, I sort of understand your explanation quite well, but he seems to be getting hung up on that. Do you want to make a few more comments about HEPAs?
I mean, a HEPA filter is great, but when you start first of all, when you start introducing a HEPA filter into an existing HVAC system, you're going to have an enormous pressure drop, and so you're going to have to increase your CFM to get past that pressure drop. So if you're going to put an in-duct fan to do the increase to accommodate a HEPA filter, you have to look at different things like that. But what I'm saying is that a HEPA filter is stated to capture, so not kill it, capture. It'll capture live virus in it, but there's no way they can give you a percentage because the virus is 0.1 micron or smaller, and the HEPA filter will capture 0.3. 0.3 micron is way larger than 1 micron. You can see the virus. They're like, you can't see them. they're tiny.
Yeah, and to your point, most HVAC systems are not going to have HEPA filters in them anyway, unless it's a doctor's office or a hospital.
Yes, yeah, exactly.
Which
Which
I'm sure there's lots of applications for that.
Brings up another point. I mean, we've done a lot of the isolation units at hospitals where they're directly exhausting the air. I mean, if you have somebody that's in a quarantine room and they're waiting for results, or they suspect that they have, like, say, TB, why would you exhaust live virus or pathogen or whatever into the airstream for somebody walking down the street to be exposed to it? We've been putting in systems in those isolation units for many years.
Yeah. So, yeah. And I guess the one last thing, and this is more to do with your odor stuff, the UVB that creates ozone.
No,
That's not
yeah.
an issue with UVC, right?
No, UVC on its own at 254 nanometers will not ever create ozone at all, ever. Now, there is some new products coming out there that's 222 nanometers. That one can. It's very close to the UVV spectrum side.
Mhm.
Now, the quartz we use to create UVV, the vacuum UV, is 187 nanometers. Now, the only time that we end up creating ozone is if there is no airflow and the lamp is on and it's continually creating hydroxyl radicals, and then the space gets filled with hydroxyl radicals, and then your oxygen molecules start bonding. And then that's the creation of ozone. So when we size for any HVAC system, we are always sizing, so we are never at that point where we're creating any ozone. It's important to have airflow. It can be just a small amount of airflow, but it's important to have 24-hour airflow so that if those lamps are on, the air is going. If you have a system where you're shutting off because of unoccupied settings and such, then that needs to shut that torpedo off. Only if you have UVV in there. If you have 100% germicidal 254 nanometers, there is absolutely no way at all that you could ever create ozone.
Okay. Yeah.
And with our garbage room applications, because if you think about a garbage room, have a garbage room full of garbage that stinks. So we have the UV treatment happening, and so there's 2 lamps in there in those units. And so the garbage truck comes and takes away the stinky garbage. So now we have a garbage room that has no garbage in it, and the odors are a lot less. And so we need something flexible that will shut off that UVV for the odor removal. And so that's where we have an ozone monitor. The shut off is at 0.025 parts per million. It's a very safe level. It's 5 times smaller than the ASHRAE recommendation. Environment Canada allow their staff to be exposed for over 24 hours at that level. So very, very safe.
Okay, well, it's been very interesting, Joanne. I guess we've burnt up an hour here, but
We
it goes
sure
by
did.
quickly. Yeah, so
Well,
we did very well.
Thank you so
And
much.
so, yeah,
Yeah.
awesome. So extremely informative. Do you have any comments, Les?
Well, I just think that you and I, Mark, we should get some rolls of tinfoil and we'll just foil around those plenum entrances, and we'll charge like $1 million to do that so we can make Joanne's raise a little bit more effective. And the other question that I had is that although air is traveling at about 500 feet per minute, how much contact time in seconds in a 10-foot plenum, which is most income plenums, is that virus going to be exposed to that light? It's moving pretty fast, so not
Yeah,
even a second,
It
right?
is. It is. This is part of the calculation I do, and this is where you would get the results and such. Okay, I tell you this. So I've been doing this for months here. So I'm just going to use 2,000 CFM. 2,000 CFM with no reflection, acoustic lining. You're looking at a biowall. To get a log 3, which is a unit of measure of kill on the first pass, because we don't want to recirculate it. So to get a 99.9% kill of the log 3 of the COVID-19 on the first pass, if it's 2,000 CFM with the appropriately sized ducts for the 500 linear feet, that one will size out to be a biowall 40. Now, if you have galvanized, then we're looking at a biowall. The acoustic line is biowall 40. Galvanized would be a biowall 30, or perhaps a 24. Again, depending on your velocity and such. Now, if you have aluminum in there for the minimum length of the torpedo, it will change to a quattro unit. So a significantly different amount. So what I'm saying is the material will dictate how long the unit needs to be, and because when you have aluminum reflecting the UV spectrum, you get a mass amount more of germicidal treatment in that space, in that ductwork.
Oh,
And
yeah.
so it's much more effective, and it's more intense, and it just reflects off and bounces off and destroys all the pathogens in the air.
Excellent. Well, that's all the question that I really had, is that I just wanted to make sure that a lot of the people, these plenums, and a nanometer is a pretty small measurement, isn't it? Like it's a million
Sure is.
of a
Yeah.
nanometer. So we're talking about the wavelength in nanometers.
Yes.
Some of our audience aren't that educated, so when we're talking about nanometers, we're talking about a very tight wavelength.
Yes, and it's on on Sanuvox.com, if you go on Sanuvox.com, they have the UV technology. They have that spectrum sheet that I showed you right there, and you can see. I would also encourage you to just Google UV spectrum and take a look at the Wikipedia page. There's an enormous amount of information on there. I mean, it talks about all 4 spectrums.
Yeah, I turned it up and there was like 1 million files I had to read if I wanted to know everything. It was
Yes,
a lot of files. I thought I would just.
it is a lot of information. But the ASHRAE handbooks, they have great chapters that have all this information in there as well.
Yeah, we reiterate a lot of that stuff as well.
I do have one other thought, and this is to do with the small room disinfection. You know, one of the downsides of some of those small units is trying to move in a CFM, and I don't know, they probably have filters. Some smaller ones may not have filters, right?
Yeah.
But
Yeah,
it's
no,
only as good as how much air you're moving around, right?
That's right. Yeah, so you can figure out how many air changes you're going to get in an hour by whatever your unit CFM is moving. And so you know, if you have a space that's 2,400 about cubic feet at 300 CFM, you're sitting about 6 air changes per hour.
Yeah, so that
So-
6 air changes an hour is the magic number, isn't it?
Well, I
Typically,
mean, that's the kind of an ASHRAE guideline. That's just what I'm. You try to get about 6 air changes per hour. It really is what. But when you have a classroom full of students and there's 30 people in that room,
then there's got to be more outdoor air.
well, yes, but you need to follow the ASHRAE recommendations of having 10 CFM per person.
Yeah.
Yeah.
It used to be 25, so
And that was like when the TB thing was around.
that's right.
I mean, UV was used then in the 30s, 40s.
Yeah.
Yeah, it's not new. Yeah.
It's not new. No, it's not new. We just sort of moved away for some reason, and it's back. Yeah.
Awesome. Okay, well, that's all I have to say. Thank you very much for your time, Joanne. I sure appreciate the effort that you gave it, and I'm sure we come along with one nugget. If you got one nugget out of this, it was well worth it.
Well, thank you so much. I don't know if you're going to share my contact information. If anybody has any questions, you can email me and stuff. And thank you for inviting me.
Hopefully you'll be advertising in our magazine, and we'll use that.
I was having a little discussion about that, and yes, I think I might look at that.
Perfect.
Okay, excellent.
And also, I think you were mentioning, Les, that you had got something going with YouTube there. So
I've downloaded
post
last month's video on YouTube. I'm glad you combed your hair, Joanne.
So then you'll be able to catch up on it on YouTube if you missed
Of course.
anything in the presentation.
I want to make a note here. We have several sand videos on YouTube. You can
Marvelous.
Google it. There's some commercial ones, there's some residential ones.
We'll put some links to our tube videos to use as well.
All right, sounds good. Thanks, guys.
All right.
Always.
All right. Have a good night. Bye.
Night.
I know.
Bye.